So what we've got here is parallel and perpendicular lines. So we're going to just revisit this and to make sure that it's very clear how you can identify if you have parallel or perpendicular lines. So to start with, I'm going to go ahead and make a foldable for this one. So go ahead and take your paper, portrait style, and then you fold it in half. Next, when you unfold it, you basically cut, like it says here, doors, okay? And you only cut up to that fold you created. So it's if you took your paper and you made a dotted line just like it is on the screen, you would just go ahead and cut into those pieces. So then you have those flaps. In other words, we call them doors. Okay, we've done some of these before. Now, you close it back up. On the outside of the doors, you can put parallel lines, perpendicular lines, and neither. Okay, parallel lines, perpendicular lines, neither. All right, so let's just go back and talk again about the form for the equation of a line. We have it in y equals mx plus c or y equals mx plus b. It just depends, again, where you are in the world. Some will use c for the y-intercept, some use b. So remember, it's interchangeable. But this is the form that it would be in. The m, again, is your slope, and it tells us how steep the line is. C is where it crosses the y-axis, so that would be your y-intercept. So if I have this, y equals 2x plus 5, I know 2 is the slope, and 5 is where it's going to cross the y-axis, in other words, the y-intercept. If I have this, it's no different. 0.5 is your slope, and negative 8 is where it crosses the y-axis, so your y-intercept. Now, when we're dealing with parallel lines, again, we're going to focus on the slopes of these lines. So with parallel lines, we know that they never are going to intersect each other. They'll never meet. So this would be good to include on the inside of your foldable, some of this information. We also know that parallel lines will have the same slope, but different y-intercepts. Same slope, different y-intercepts. That forces them to go ahead and be parallel. So on the inside, once you open your flap for parallel lines, you may want to include this information here. Parallel lines never intersect, and parallel lines have the same slope. You can also put the markings on there, because remember we talked about marking up parallel lines previously. Now, lines that are parallel to this example. We have y equals 2x plus 5. If you notice, all of these examples that you're starting to see pop up, they all have a slope of 2. And so that's how we know that they're parallel. The slope is the same, and then if you look at the y-intercepts, all of the y-intercepts are different. Okay? So examples of lines that are parallel to y equals 2x plus 5. Perpendicular lines. Well, as you see here, the slopes are negative reciprocals of each other. Remember, perpendicular lines will meet at right angles, so they'll form a right angle. But also, if you multiply the slopes of perpendicular lines, you will get negative 1. So there's two ways to look at this. You can look at the slopes, and if you multiply the two slopes of two different equations together and you get negative 1, you know they're perpendicular. The other way is if you look at the two slopes and one is a negative reciprocal, remember reciprocals when you flip your fraction, if they're negative reciprocals, then that's also going to tell you you have perpendicular lines. So on the inside of your flap, you can always draw these diagram and put these facts. So these are some facts for you to write down. Perpendicular lines intersect to form a right or 90-degree angle. The slopes of perpendicular lines are opposite sign reciprocals of each other. If you multiply slopes of perpendicular lines, the product will be negative 1. So here are some examples to go with this. So we said slope 1 times slope 2 should equal -1 for perpendicular lines. So 3 times -1/3 gives you -1. So any line with a slope of -1/3 would be perpendicular to y equals 3x minus 8. Okay, so just to recap one more time, if we have all these numbers, you could pause the video here and you could practice this and try and figure out which ones are perpendicular. So for 3, we got -1/3. For 7, -1/7. For -9, it would be +1/9. For -5, it would be +1/5. For -1/5, it would be +5. And for -2/7, it would be +7/2. Again, those would be the gradients or slopes. Remember, gradient and slope is interchangeable. Finally, you may end up with neither situation. So if the lines intersect, but they don't form a right angle, then they're neither parallel nor perpendicular. And the slopes are not equal nor opposite sign reciprocals. And that's the quick review of parallel and perpendicular slopes.